Hello everyone. In this video, I'm going to discuss a word problem for which first we have to uh, find a function and then we have to sketch the resulting function. So this problem needs a little bit more work than the regular curve sketching problems because the ones I discussed before, the function was already given. But here we first need to evaluate the function and then we need to sketch the function. So take a moment, pause this video and read the question. So we have an open rectangular box which is used for storing chemicals to be made from 10 square meter of matter. So it means the surface area of the box is 10 square meters and it has an open top. Must have a square base. So the base is a square, so it means all the sides should be equal, and we have to express the volume as a function of the side of the base. So basically we want to find volume as a function of x. So and then draw a sketch of the resulting function. So first question is this and second function is sketch our volume function, so which is our Vx. Let's say the height of this box is y. So if we try to write the volume, so volume should be length times width times height. So in other words, volume should be x square y. So I'm just going to call this number 1. And now our goal is to express this exclusively in terms of x only. So it means we need to figure out the value of y. So for that, we are given additional information that we're going to use. So the area is 10 square meter and there is no lid for the box or no top for the box. So area is equal to 10 square meters. So it means, so area of the floor, so that is the base x square, and then area of the 4 walls. So each wall has one length is x, another length is y, so 4 times xy equals to 10. And we can solve here for y. So our goal is to find the value of y. So we're going to find y and then plug into our volume equation. So in this case we get 4xy is equal to 10 minus x square and y is equal to, so divide both sides by 4x, so we get y is equal to 10 minus x square over 4x. And now we're going to put this value in the given volume equation that I just formed in the beginning. So volume is equal to x square, and in place of y we write 10 minus x square over 4x. So overall we get, so x and x cancel, so we get x over 4 10 minus x square. And since we know that in order to sketch the function I have to find the critical value, so I'm just going to rewrite this as 1 over 4 10x minus x cube, so that is easily differentiable. So that is our volume function which we want to sketch now. So part 1 of the question is done. So first, in order to do the sketching, first we're going to find the roots of this function, like the values of x where the function crosses x-axis. For that, we set function equal to 0 and we solve for x. So this means 1 over 4 10x minus x cube equals to 0. In other words, the factor 10x minus x cube is equal to 0, and x is a common factor, 10 minus x square equal to 0. So from here we got x equal to 0 or x square equals to 10, which means x equals to plus minus square root of 10. But since x is the length of a side, so it cannot be negative. So x has only two values, x equal to 0 and square root of 10 in this case. All right, so next we're going to find our critical values. In order to find the critical values, we need to set the first derivative equal to 0. The first derivative in this case would be, so we are going to differentiate this function. So here we have 1/4 outside, and then derivative of 10x would be 10, and derivative of negative x cube is going to be negative 3x square. And first derivative equal to 0 implies this whole thing equal to 0, which in turn implies that 10 minus 3x squared should be 0. And from here, 10 is equal to 3x squared, or 10 over 3 is equal to x squared, and taking square root on both sides, we get x equals to plus minus square root of 10 over 3. So again, we know that x is the value of a length, so it cannot be negative. So we only get the positive length. We have only one critical value here. So this is approximately equal to 1.83. So approximately equals to 1.83. All right, so now we need to decide whether it's the point of maxima or minima. And for that, we can use the second derivative test because it's easier to take the second derivative. So from here, the second derivative would be, so 1 over 4. So derivative of 10 is 0, and derivative of negative 3x is negative 6x. So overall, we get negative 3 over 2x. And now if I put the answer, if I put our critical value here, so square root of 10 over 3, and since we know that this is always, because x is positive, so it's going to be negative. So this is negative since x is positive. So it means it's concave down. So concave down means this must be a point of maxima. So the point of maximum, so maximum value A is, so you can find the maximum value of the volume when x is equal to square root of 10 over 3. So volume is given by this function, so put x equals to square root of 10 over 3, and we get the maximum value is approximately 3.04. So our point of maxima becomes square root of 10 over 3, 3.04, or in other words, we can say 1.83 and 3.04. So I just converted this in the decimal form so that when I do the graphing, so I can locate the points on my graph. So now we're going to sketch our function. So far we have found that the roots are x equal to 0 and square root of 10, which is 3 point something, and the maximum value is 1.83. So the point of maxima is this one. So 1.83 and 3.04. So let's do the partitions on our, or the scaling on our graph. So this is your x values. Here you have your volume values. First, we're going to draw our roots. So root are 0 and square root of 10, so which is going to go a little bit more than 3. So these are our two roots. And then the maximum value is 1.83, and x is 1.83 and y is 3.04. So 1.83 is close to 2 and 3.04 is going to be somewhat here. We're gonna join all these together freehand, all these points. So this is a rough sketch of our curve. So square root of 10, 1.83, 3.04, and this. So I hope that makes sense. So sometimes if you have a word problem, you have to make your own function first, and then if they ask you to do curve sketching or find the related rates, just do whatever is asked in the problem. Thanks for watching this video. In the next video, I will discuss some word problems that are related to finding maxima and minima of a function.